Next section that we have to cover is section 11-5, which comes right after 11-4. Hopefully you've taken the quiz over 11.1 through 11.4 already. If you haven't, get that taken care of here relatively soon. We're going to kind of keep digging into logs today. With this lesson, probably two lessons today, section 5 and section 6. Section 5 really is going to be pretty easy. It's going to be a lot of calculator stuff today. So you're going to evaluate common logarithms using a calculator. Evaluate natural logs using a calculator. And then, which gets a little bit more confusing, is the change of base formula. So a lot of calculator work today. Should be a pretty quick little lesson. So evaluating common logs. Common logs are the logs that are on your calculator. So you see the log button on your calculator. A common log is a log with a base of 10. We use calculators to evaluate common logs. These give an approximation to logarithms, and we're going to give them to 4 decimal places. 4 significant digits is oftentimes what you see. But we talked about it a little bit the other day when we said, and I had you actually find some of these. Anytime you see something like log of 4, that means log base 4. That means log base 10 of 4. That's what your calculator understands. Your calculator understands things with log bases of 10. Okay, so we're going to work on evaluating them today. So evaluate each logarithm to 4 decimal places using a calculator. Literally, all you're going to do for these. If the base isn't there, if there's nothing there, or even if there's a 10 there, you're going to go to your calculator and hit log. It's right there. 41600. Hit enter. That's what you get. That's your answer. You're done. Okay. Log base 10 of 43.5. That's what you get. You're done. Log of 0.442. That's what you get. It creates a ratio for you. Essentially what it's saying is like for log 43.5, it's saying 10 to the, it's really what this says is it says that 10 to the 1.6385, that's equal to 43.5. That's what that says. Okay? And that's what logarithms do. Okay? They're kind of that inverse of exponential form. They allow us to find that exponent when things appear to be more difficult than they actually are. So common logs and applications, pH values. Yeah, great. Okay, another example, great. Evaluate natural logs. Now the natural log is the ln. We talked about that in the last lesson. It's ln or e. So again, it's on your calculator. It's right underneath the log button, right there, backwards, but it's right there. So to find it on your calculator, ln 0.01, enter. That's what you get. ln 27, that's what you get. ln 529, that's what you get. And essentially, remember, ln is the same thing as log base e. So it's essentially saying e to the 3.2958 is equal to 27. E is that natural log that we've talked about. Okay. Natural logs and applications, perfect. Now, what happens if it doesn't have a base of 10? If it doesn't have a base of 10, we have to use what's called the change of base rule. What the change of base rule says is this. It says log base a of x. And a can be anything. Your base can be anything. That's good. That's going to equal log base b of x over log base b of a. So you guys look better with numbers. So if I have log base 4 of 10, this is equivalent to the log of 10 divided by the log of 4. So you go into your calculator now and hit log of 10, close the parentheses, divided by log of 4, close the parentheses, and you get 1.661. It's 10, but it's 096, blah, blah, blah. But that's the change of base rule. You'll hear me say formula probably a lot because that's how our other book talks about it, is the change of base rule. But it allows us to do things without that common base of 10. If it's a base of 10, remember, just hit log. If it doesn't have a base of 10, this is what we have to do. Okay, so if we want to find the log base 3 of 17, this is the log of 17 divided by the log of 3. They write it all out. They put a 10 there. We don't need to put the 10 there. It's understood to be there. The log of 17 divided by the log of 3 is approximately 2.5789. Again, check it on your calculator. Log of 17 divided by log of 3. That's what I got. It's called the change of base formula. We're going to do a few more of those. I'm not real keen with the number that they did there. So let's do a couple more of those. Let's go log base 6 of 13. It's always going to be the log of our of divided by the log of our base. Base goes on the bottom, the of goes on the top. Log of 13 divided by log of 6. 1.4315. Last one. Log base 13 of 4. It's okay. This is the log of 4 divided by the log of 13. Big number's not on the top, small number's not on the bottom, doesn't matter. It's the base is on the bottom. The base, remember, is a log base. Base is on the bottom, the of is on the top. Log of 4 divided by log of 13, 0.5405, or 0 point. There it is. That's the change of base formula. That's it for section 5. That's all you have to do. Should be quick. Punch calculators real quick, and you can get done with this one in record time. 7 minutes and 15 seconds to be exact. Next one that we have to work on then is section 11.6, and this is the final section of this chapter. We're going to kind of put it all together now and work on solving equations involving variable exponents, solve equations using logarithms, and we're going to come back to the compound interest formulas in a different lesson. We're just going to kind of take care of those first two objectives today, solving equations using variable exponents and involving logarithms. So we've talked about all these different properties. You should have all of these down in your notes already. Could be good to go. So let's go ahead and solve equations now. So we're going to solve, and we're going to give the answers in decimal form. So we want to find the value of x that makes this work. So the first thing you need to determine when you're doing these is it in exponential form to start out with, or is it in logarithmic form to start out with? Okay, you don't see the word log and you don't see ln. That means it's in exponential form. Simple as that. If you see the word log, it's in logarithmic form. If you see ln, it's in logarithmic form. If you don't see those two things, it's not in logarithmic form. So it's in exponential form. In order to solve these, you need to put it in the other one. So if it's an exponential form, in order to solve it, we want to write it in logarithmic form. That's why the first few lessons in this chapter were so important, being able to convert them. If it's in logarithmic form, you're going to write it in exponential form. Kind of do the inverses to kind of help us solve it. So we have 10 to the x power equals 4. So that's exponential form. So we're going to go ahead and rewrite it in logarithmic form. So in logarithmic form, that's log base 10 of 4 equals x. Well, we can just solve this on our calculator. Base is 10, so since the base is 10, it's just log 4 on your calculator. 0.6021 is the solution for that, and you're done. And that's all you have to do for that problem. It's in exponential form. Write it in logarithmic form. If it's in logarithmic form, write it in exponential form. They do it a little bit differently, and I don't like how they do it. Do it the way I did it. My way's easier. Okay. E. Ooh, an E. What does that mean? Well, it's still an exponent. You don't see ln and you don't see log. But remember, E is the natural log. Okay, so we have to write this in logarithmic form. It's in exponential form because it's to a power. You don't see log, you don't see ln. Okay, so I like to, when I do these, I like to write this as log base e of 192 equals 0.02x. Remember, log base e isn't anything we have on our calculators, but remember, log base e equals ln, so I can change this to ln of 192 equals 0.02x. ln of 92, that's a calculator punch. ln 92, I'm not going to write that number down, but it's that. And think about what you're going to do. Well, I'll write it down. So it's 4.521-ish. That's going to equal 0.02x. We have to solve for x. So how do you solve for x? You divide by 0.02. When you divide that by 0.02, you get 226.089. And you're done. And that's the value for x that makes that work. Exponential form, write it in logarithmic form in order to do these. Okay, and again, they're going to do it a little bit differently than I do, but that's okay. It's approximately the same answer. Okay. So we're going to do a couple more of those before we go on to the next objective. Obviously, 2 is probably not enough. So let's look at a few more. Let's go 6 to the x plus 4 equals 10. Okay, so it's in exponential form, so I have to write it in logarithm form. So that's log base 6 of 10 is equal to x plus 4. Log base 10 of 6, can't do that on a calculator, have to do the change of base formula. So that's the log of 10 divided by the log of 6. That's going to equal x plus 4. Change of base rule or formula. Take out the calculator. Log of 10 divided by log of 6. You get a decimal, 1.285, something like that. That equals x plus 4. Just don't hit clear, because we have to subtract 4 from both sides. And then we get an answer of x is equal to negative 2.71, blah, 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 blah. 49 is the solution to that. But again, it's an exponential form. We write it in logarithmic form in order to. So let's go e. So let's go e to the 3x equals 8. It's an exponent. Write it as a log. Log base e of 8 equals 3x. Remember, log base e doesn't exist. That's not on a calculator, but it equals ln, so I could rewrite this as ln 8 equals 3x. Now I'm just going to divide by 3 here right away, so I can take ln 8 divided by 3. Make sure you close parentheses after the 8, and I get my answer right away. 0.6931 is equal to my x value. So anytime you have something that's in exponential form, in order to solve it, write it as a, so we have something like log base 3. We're going to get rid of that. If we have something like log base 3 of x plus 1 equals 3. That's a log. If you see the word log or you see ln, that's logarithmic form. So we need to deal with it. So do you deal with it by changing it from a logarithm to an exponent? My base is 3. It's a 3 over here, so this would be 3 to the third equals x plus 1, because we changed the problem. 3 times 3 times 3 is 27. Subtract 1. That's a 6. 26 is equal to x. Done. Okay, and you move on again to the next question. If it's in logarithmic form, so let's look at another one. Let's go log base 3, 2x equals 4. Logarithmic form, clearly logarithmic form. So 3 to the 4th equals 2x. 3 to the 4th, I think, is 81. I can check on my calculator. 3 raised to the 4th is 81. So 81 equals 2x. Divide by 2. 40.5 is equal to x. And you're done. If it's in logarithmic form, rewrite it as an exponent. Well, what if we have the natural? What if we have ln of 6x equals 15? That's logarithm. It's written as a log. Remember, and this is what I like to do when I get these types. I like to, again, change the ln to log base e. So log base e of 6x equals 15. So now when I do that, I can write it as an exponent pretty easy. I see that it's e to the 15th is equal to 6x. So divide by 6, and we're going to get our x value. So e is second ln. Take that to the 15th. Divide by 6. You get a huge number, but that's okay. 5444836.2287. Big number, but it's okay. But yeah, so let's do another one of those. So let's go ln of 2x plus 4 equals 3. So it's an ln. I don't like it written as ln, so I'm going to rewrite it as log base e. Now I can write it as an exponent. E to the 3rd equals 2x plus 4. E to the 3rd I'm going to do on my calculator. And I probably won't write that number down. It's 20-ish. But then, well, I always say I'm not going to write it down, but I always do. So that equals 2x plus 4. So I'm going to subtract 4. And divide by 2. That's a 16. So you get 8.04 is equal to your x value. But again, it's in logarithmic form. Change it to exponential form and solve. So notice we've got two logs being added together. Anytime we're trying to solve logarithms, you want to have a single log. So we talked about the different properties for single logs. And what we said was that if you have two logs that are added together, that's the same thing as multiplying them. So log base 8 of 2x plus 5, we can take 2x plus 5 times 3, which is 6x plus 15. And now that's going to equal log base 8 of 33. Well, this one's a little bit tricky. Not a little tricky. I mean, it's, if you think about it, I've got log base 8 on both sides of the equation. I could divide by log base 8. Not that you would, whatever. Log base 8. Those things are really going to cancel each other out, so to say. So then you can just solve the equation, 6x plus 15 equals 33. So 6x equals 18. X equals 3. Okay. So if you get more than one log, okay, you've got two logs there added together or subtracted from each other, make sure you write it as a single log using those properties that we talked about in lesson 11.4, I believe, is what lesson that one was in. And again, they do them a little differently than I do, but same answer. Did we get 3? Yeah, we got 3. Cool. Okay, now let's look at this one. Now it doesn't equal a log on the other side, but that's okay. We know how to do it, but we still have to write it as a single log. So we have log base 3 of 2x minus log base 3 of, so it's minus, so it's going to be a little ugly in here because there's some dividing going on, but that's okay. So we can rewrite this as log base 3 It's minus, so that means I'm going to have 2x over 3x plus 15, and that's going to equal negative 2. So it's a logarithm. So since it's a logarithm, we need to write it as an exponent. So that's 3 to the negative 2 is going to equal 2x over 3x plus 15. Well, 3 to the negative 2 is 1/9. So I've got 1/9 is equal to 2x over 3x plus 15. We can cross multiply. 2x times 9 is 18x equals 3x plus 15. That's 15x equals 15. Math is cool. All of that, and you get a value of x is equal to 1. Moral of the story, you have to write it as a single log. Once you've written it as a single log, then write it as an exponent and solve. Let's watch them do it. Isn't that pretty? Same answer. Okay. So there is section 11.6. That's the last one in this section. So 2 short lessons today, 2 quick lessons today to get both 11.5 and 11.6 taken care of. So that should do it for this week. Have a great weekend, everybody. We will see some of you on Monday. We'll see some of you, the rest of you, on Thursday.